Welcome. This video is about formatting strings with format strings. The support in Rust for formatting is quite sophisticated and follows the standard conventions we already have. However, there's a big difference. There's compiler support. Therefore, filling in format strings and stuff like this is supported by the compiler by type checking. We'll see this in the examples. We begin with some easy examples. There's a fundamental macro called format with an exclamation mark to indicate it's a macro. It produces a string, so it doesn't directly send it to any file or output or whatever. It produces a string. All the others essentially are based on this. The first argument is a format string, and it used a pair of curly braces to indicate the position where something should be filled in. That's similar to what Python does with formatting. If you just put an empty pair, then you can essentially put an arbitrary value. We'll come to this later as an argument. And the number, if you put multiple pairs, then you can put multiple values here. And the thing is that the compiler actually looks at the types and knows what actually to do and for what code to generate. For example, you can print integers, strings, floats, string slices, references to strings, Boolean values, and you can use print line to format and already send to standard output, followed by a line feed, or you can use print. Then it's not followed by a line feed, and you have the same thing for the standard error by using ePrintLine for printing a complete line and ePrint for just printing without an line end. So let's see this in action. Indeed, we see here the integer, the float, the string, and everything works exactly as expected. The next topic is to indicate what to print. There are several ways to do that. The most common one is that you have multiple curly brace pairs and just give multiple arguments. Then they are filled in the order in which they come. However, you can also use zero-based integers to indicate which argument to print. So this here would print first the content of t and then the content of 0. Or you can indeed use a variable name here. And if nothing is given behind here, and this t just belongs to this brace here, then it takes the variable which is currently bound to that identifier here. So this prints s here and t here because nothing is given here. And the third possibility is that you give it an identifier, and at the end of this argument list here, you use this identifier to assign an expression. So here you can have an expression and give it the name u, and that is filled in here. Whereas here, if you just put the expression, the name of something in the scope, then you can just put a variable name. So you cannot put expressions here, but if you need expressions, you have to give them a name and use this syntax. Let's see this in action. As you can see, we see here first the string and then the number, here the string and then the number string, then the string, and again the other two cases. And that's because here it's in order st, first the string and then the number. Here it's the opposite order. Here it's the first order again. And here we have t, the number here, and the named expression here, which comes out as a string. You can, as you know from other formatting libraries, you can give the width of the field for which the item is printed with giving a colon followed by an integer. Furthermore, you can give an alignment, that is, you can right align it or left align it or center align it. Note that numbers are by default right aligned, whereas strings are by default left aligned. But as I said, you can use the greater, less, or array operator to align what you want. For floating point numbers, you can also give a precision, which is a dot after the width of the field, followed by the precision. So let's see how this works out. This is the print of the float without a width. This is the first one with a width but no alignment, and the default is on the right. Then you have right, left, and center alignment. For strings, the default is on the left. And then you have explicit right, left, and center alignment. And here you have the same value right aligned with precision 4. Here it's left aligned. Look at this again. Here number right aligned, precision 4, and here left aligned. Next is fill and other options. You can give one character after the colon, but before the alignment, which is the fill character. So for example, here you fill with stars. Here you fill with stars, and after the alignment character, using a plus for numbers means that the sign is always printed, even if it's plus. And giving a hashtag means that it uses the alternative form. And we'll cover this in a second, but the X is for hexadecimal, and the alternative form has the 0x prepended, and not just the hex digits. Notice that I print a vector here, but I demonstrate the alternative form. Usually I have to use the debug notation, colon, question mark, but I use the alternative form for pretty printing. As we can see, you have filled with stars, and with printed sign. Here you have a hex value, but with 0x prepended. And here you have the pretty print form of the vector output, which would otherwise be in one line. I've already mentioned hexadecimal. There is, for numbers, normal output, binary output, octal output, hexadecimal with capital letters. Then, of course, for float, there is scientific, and scientific with capitalized E. And an interesting one, you can print pointers by using the P modifier here. The P modifier, or all these modifiers, come after width and precision, potential if they are there. So they are essentially the last thing. And quite a few of these have alternative notations with putting a hashtag before that. Let's see this in action. Here we have a number in decimal, we have the binary number, we have the octal number, we have hexadecimal with small letters and with capital letters, we have scientific notation with E and capital E, and we have a hexadecimal pointer display for giving the address of a reference. I've already mentioned the debug formatting, that's colon followed by question mark. That works for the normal types as well as the normal printing, for example, for strings, numbers. But if you want to print structs or vectors, then you have to do two things. First of all, you have to use the debug printing here, and then you have to give this derivative, this statement here. You have to derive debug for your struct by putting this statement just in front of the struct. Then you get a nice display of the struct. And for vectors, this is already automatically done, and for quite a lot of other data structures as well. Let's see this. Here we see the debug output for strings, floats, and integers. That's the debug output which was derived by the directive from a struct. That's a vector, and these are just two plain numbers. For fun, I've put nearly everything we saw together. There's actually even something new. For example, if you need a closing brace, then you can just put two braces, and likewise with an opening brace. Secondly, the other thing I haven't covered yet is that you can have the width specified as runtime value. You do this by specifying where the width is and then using a $sign. For example, here I use a named parameter with a $. So this is the width field. I could also use, say, 1 here for the index of the thing here, and thereby have the field width at runtime. Now let's look at these complex examples here. Here I select what to print by giving an identifier, which is then taken as the currently in scope identifier here. I fill with minuses, I use center alignment, I have the sign printed, and the field width is 20 and the precision is 4. Note this order. It's always what you want to print, then a colon, then a potential fill, alignment, then the modifier letter, and then the width and precision. That's the order. And then the last thing is the way you want to print it, the printing trait. So here, V is the named parameter down here. Then there's a fill with stars, it's center alignment, it's a modified alternative form, filled with the 30, and we have hexadecimal printing. Here it is print argument number 0 based. Then I have a question mark to fill with question marks. I have right alignment, filled with 20, and pointer. And here I have the value which I put here, again the number, with the runtime given width of 30 in this case, and precision 4. So let me see this in action. Indeed, it is what we expect. Let me demonstrate quickly how the compiler actually checks the format here. If I, for example, put a colon here, then the compiler says something about an opening brace here. Let me see the full message. If I do cargo build, I get invalid format string, expected closing brace. Yeah. So this just doesn't make sense. And because of this closing brace, it expected here already a closing brace because this colon comes unexpected. So since the compiler knows the syntax, it can actually help us to syntax check the format string, and it can help us to see whether we got the types right. For example, if I here have hexadecimal printing and I give a string here, then it will immediately say the trait bound string lower hex is not satisfied by this type. So we have actual type checking and checking the number of arguments, and that's a huge improvement over C++. I know this video was long, it showed a lot of stuff, and I'm sure you cannot remember everything. However, together with the accompanying web page, I think I've given you an impression and an overview over the facilities for the string formatting. And if you want, you can always go back to the web page, look at the code examples, and look up what you need. Or alternatively, follow the links to the documentation and find your way around this way. I hope you enjoyed the video, and see you in the next one.